Alrighty folks, I want to show you how to create a simulation for your CO2 racer body in Onshape. So if you followed along with what we have done, you've created a project in SimScale, you've imported your body design, and we talked about how to create this mesh to perform our calculations on. So you should already have a mesh generated, and it'll give you some options. We're just going to go through the list step by step, and I'll show you what you need to put in for the inputs to simulate a CO2 racer. So here for materials, it's pretty simple. I'm just going to select air. The bounding volume of our mesh is going to serve as, that's air. We're essentially trying to simulate a wind tunnel here, and so you can select a certain volume under Pick Volumes. You can also access that information from the geometry menu on the right side of the screen. Pretty easy. Default settings should work fine for what we're doing. Alright, don't worry about the initial conditions right now. We'll just leave those, whatever they are, default. We are going to set up a couple boundary conditions. And so you can hit this little plus sign to create a boundary condition. And all we need to do is tell the software what each of these faces of our bounding box for a mesh are going to do, what physically is going to happen here. And so the first one I set up is a velocity inlet. Under boundary condition, you can select velocity inlet. I'm going to choose 20 meters per second to simulate my CO2 racer. And under the assignment box, I'm going to pick this front face of my wind tunnel. So what this just means is that I'm going to simulate velocity of air, a flow of air coming through this particular side of my wind tunnel. Okay, so if the air is coming in, it's got to come out. And there's not a velocity outlet per se. Because I got something in the middle that the air is running into. What I'm going to do instead is use a pressure outlet, and I'm going to treat this backside of the bounding volume of the mesh to be an outlet for air pressure. So I want that to maintain air pressure of 0 pascal. So I'm just going to click the backside there, pressure outlet, easy peasy. Alright, next I'm going to set up some walls. And there's a couple different wall settings you can use within SimScale. The first thing I'm going to do is select wall here. I'm going to select what's called a slip wall. And so slip wall just means that in my particle simulation, like the air can slip past where the wall is. And so like the sides of this wind tunnel, they aren't actually like a physical wall. They're just the bounds of my simulation. And so I'm going to, under assignment, select the side, the top, and the other side, and they're going to be slip walls. I'm going to select add another wall, and I'm actually going to select the bottom edge here, which would correspond to the road or the ground that our car is driving on. And I'm actually going to select a moving wall. And the wall is going to be moving at the same speed as my air's flowing, so it's the same speed as the wind flowing. It's just going to simulate the car driving along the ground. So, if the car is moving at 20 meters per second relative to the ground, well, the ground's moving at 20 meters per second relative to the car. Be careful here with specifying the directions. Again, I'm looking at the little cube here in the bottom right-hand corner. My wind flow is coming in through this face, exiting this face. That's in the positive x direction. Depending on how you have your model oriented and how you have your bounding volume made, you may need to adjust which direction you're specifying that this is moving. So 20 meters per second in the positive x direction, that's my road wall. And finally, I'm going to set up one wall that's going to serve as the bounding box for the actual model itself. So this is going to be a wall. It's going to be, in this case, a no-slip wall. So that's where, of course, the air is going to hit the surface of the wall. It can't go through that wall, so it's going to bounce off the wall and do some, whatever physics it's going to do. And so that's where I've got friction with the wall, no movement between the wall and the fluid that's flowing through this wind tunnel. So to select the faces, you can use the face select tool up here. I find it easier to go here to my geometry menu and hit the little plus sign there, and you can select the faces of your solid right there. All right. Hit the check mark, save that. Easy enough. Numerics and simulation control. This is where you set up the settings for your simulation. I think the default settings should work fairly well with what we're doing. But what I am going to go in and look at is result control. We need to create a forces and moments result. So we're telling the computer this is what I want to calculate. And this is what I'm going to need to calculate the drag coefficient. So first thing, hit this little plus sign. Then we're going to create a forces and moments. All right, so that setting's all fine with me. Select all the faces of your car, and that'll just let us calculate the forces and moments affecting this model. Hit the little plus sign next to forces and moments again. We're going to create a force and moment coefficient. Center rotation's fine. Lift direction, if you think about this thing having lift, the lift direction would be up, which in this case, again, looking at this cube in the bottom right-hand corner, is the positive z-axis. So I'm just going to put a 1 there for the lift direction. Same idea for the drag direction. If my car is moving in the negative x direction, my drag force is going to be in the positive x direction. So I'm just going to put a 1 there for the drag direction in the x direction. Hopefully we don't have any pitch here, so we don't have to worry about that. The next couple settings are things we're going to have to possibly go back to Onshape to figure out. Free stream velocity, we can just use the speed of the wind in the direction, so that's 20 meters per second. For the reference length and reference area volume, I may need to go back to Onshape to find what those values are. So let me switch back to Onshape real quick. Let's see, here's my box racer. It's pretty easy to figure out the reference length. I mean, we're talking about the length of this design. Click that, bam. Onshape gives me the calculation for the length. Same idea for the reference area. So if I look at this from the front view, I'm looking for the front area of this car. And so this right here is my front area. For something simple like this rectangular prism that's just one shape, I can calculate it's 0.00105 meters squared. I can plug that in Onshape pretty easily. Chances are you're going to simulate something that's slightly more complicated. Here's a potential design. Here's a little wedge racer. If I look at something like this from the front, I've actually got two shapes that comprise the area of this racer. But if I look at this, what Onshape's actually calculating is the area of this front piece and the area of this whole long rectangle. I don't want that. What I just want is the area of the rectangle from the right side view. So calculating that's going to be a little bit tricky, but here's a trick with Onshape that you can use to actually get the front area of this car. I'm just going to create a sketch. I'm going to create a sketch plane just in this plane that's parallel to the front face, which in this case is the right side in Onshape. I'm just going to select my whole model. I'm going to use the project tool, and that's going to take my model and put it into the plane. And if I save that sketch, hide my eraser here, that is the actual front view of this object. So if I select that, hit the little measure tool down here, that's going to give me the actual front area of this car, which in this case is going to be the same as my rectangular racer because I use the same dimensions there. If I have something slightly more complicated, like here's a curvy racer, it's got the CO2 canister holder contained, I can do the same thing. Create a sketch, the plane parallel to the front view of your racer. Just select all the parts. Use that, project that into your sketching plane, save that, hide your volume, and you can use that as your front area of your car. And so again, that's a little more complicated design. There's a little more filleting and curves, so it's a different area. So that's how I can get my reference area to use in my simulation. So let me go back to my simulation real quick. I've got that entered in there. Again, I'm going to select the faces of this CO2 racer. You can use the assign face tool, or you can use the geometry menu on the right side. But those are really the only 3 values that I need to specify here. The default settings should work fine. And that's it. That's all I need to do to set up my simulation. So once you've got that set up, you should be ready to run your simulation. Cool. So that should say run simulation. In the next video, we'll take a look at actually how to look at and understand the results of your simulation.